In number 4, we want to rewrite this as 6 to the u half, 6u to the 1 half plus u to the negative 1 half inside the integral. And then we can do the antiderivative by adding 1 to each exponent and dividing by the new exponents. So we add 1 here, we get u to the 3 halves, divide by 3 halves, or you can think of it as multiplying by 2/3, right? Multiply by the reciprocal. So we end up with 4 times u to the 3 halves. Then we do the same thing. For this one, add 1 to the exponent, we get u to the 1 half, divide by 1 half, or multiply by 2, we get 2u to the 1 half, and then we have to remember the plus c. 5 and 6, we're not going to go through the whole problems for each of these, just kind of explain what you need to do. Remember, we want it to be like this, a number times a variable to an exponent. We can't have this squared here, or we can't have two of them being multiplied. So here, what we're going to do is distribute. All right. Same thing with this one. We can write this as 2x minus 1 over x times 2x minus 1 over x. So in both of these cases, we have to distribute before we do the antiderivative. We're going to distribute and take the antiderivative. Alright, so we're not going to go through how to do those. I think that's pretty self-explanatory and you'll be fine with that. Let's take a look at these last two because they're a little bit tougher. Number 7, for this one, we can rewrite this. This is like antiderivative of 7x squared minus 5x plus 4 all over x to the 1 half dx. But that's not enough to rewrite it. We can't just do like the antiderivative of the top divided by the antiderivative of the bottom. It doesn't work that way with like division or multiplication like it does with adding and subtracting. We have to rewrite this still. So one way we can think of this is to take the antiderivative of that whole top times the bottom. So think of the bottom instead of x to the 1 half, think of it as x to the negative 1 half. So we can write it like this: 7x squared minus 5x plus 4 times x to the negative 1 half dx. So we can distribute that x to the negative 1 half to each of these. And remember, when we multiply two powers of the same base, we add their exponents. So this would become 7x to the 3 halves minus 5x to the 1 half plus 4x to the negative 1 half. So now we can do the antiderivative of that one. Right? Add 1 to the exponent, so we get x to the 5 halves. And then we divide by 5 halves or multiply by the reciprocal. So with fractions, it's best to think of it as multiplying by the reciprocal. So 7 times 2/5, we get 14/5. On our next one, we're adding 1 to the exponent, so it becomes x to the 3 halves. Multiply by 2/3, so we get minus 10/3. Last one here, we get x to the 1 half after we add 1 to the exponent. Divide by 1 half or multiply by 2, we end up with 8 times x to the 1 half, and then we need to remember our plus c. And then for our last one here, we can't do the same thing when there's the x minus 2 on the bottom. So with this one, what we're going to need to use is synthetic division. So we can divide this synthetically. We put the 2 out in front. Our coefficients, 1, 3, negative 9, and negative 2. So bring the 1 down, multiply these, add those up. So we end up with, if we divide those, we end up with x squared plus 5x plus 1 inside our integral. All right, so now we've got a simple expression that we can take the antiderivative of. 1/3 x cubed plus 5 halves x squared plus x plus c.